Okay, so today we're looking at measures of dispersion, guys. So we have looked at calculating measures of central tendency, so mean, median, mode, and really looking at those quartiles, quartile 1, quartile 3, doing a box plot so you can kind of see the spread in that box plot. But now we're looking at more values that are more commonly used to compare data. So, although a measure of central tendency is valuable, this is not the only important statistic. A measure of the dispersion or spread of the data is also important. Examine the frequency tables below that summarize the marks on test 1 and test 2. Question 1, use the stat function on the graphing calculator to find the mean of each set. So if you get out your calculator and go to edit, clear off any list that you have in there. We're going to enter both lists at the same time. Test 1 will be in L1, test 2 will be in L2. It's balanced that way. Oh, I shouldn't say that. Test 1 will be in L1, L2, and test 2 can be in L3, L4. So here the marks, 9, 10, 11, 12, 13, 14, 15. L2 will be the frequency of those. So 4, 3, 7, 8, 6, 5, 3. Okay. Test 2, take a look. Those values for the marks are exactly the same. So I'm not going to put it into L3. I can reuse L1. My frequency for test 2 will go into L3. Okay. Again, save yourself some time. So 1, 1, 8, 18, 7, 0, 1. Okay. Make sure they all line up. You didn't add an extra one or forget one. Right? Oops. Yep, that's good. Just checking them. Quick check. Okay. So, stat function. And we're going to do some calculations. Remember, it's always one variable stats, even if you're using two lists. Frequency. So, one variable stats. Let's do it for test 1. So our marks are in L1 and our frequency is in L2. So then you go second, number 2, the blue L2. Calculate on that. Okay, and we're looking for the mean. So the mean in the calculator is X with a bar over it, and so that's 12. So, so for test 1, the mean equals 12. For test 2, let's get the mean for that. So quit out of that screen, stat again, calc again, one variable stats again. We're leaving L1 the same because it is the same in both tests. But now our frequency for test 2 is in L3. So second 3. Now enter on that. And you get 11. If we could round to the nearest tenth, 11.9. Okay, very close to the same mean. Oh, yes, what did you just do? There you see it. You need interjections, no paper. Okay, so using the graphing calculator, draw the histogram of marks given this window. So go to your window, change it to 8.5 to 15.5, scale of 1, and y min, -1 to 19, so -1 is already in there for me, 19, and going up by 2s. Okay. So you can go, if you go to y equals, probably should go there just to check. If there's any graphs in y equals, clear them off. Then for plots, I see that I've got a plot 1, but I can't remember what I last graphed. It was probably a box plot. So go to second y equals and enter on plot 1. We want to keep it on, so make sure that's selected, but we want to go to that bar graph or histogram. So enter on that. It was a box plot. Then the X list was in L1. Okay. Frequency list is not one of each, it's in L2. So second 2 is L2. Okay. Enter on that. Now, you can go back up, actually right away. Actually, that turns it on. So let's quit out of that. We've got in our y equals, we've got plot 1 the way we want it. Now let's go to second y equals and turn on plot 2. Okay, so turn that on, change it to a histogram or bar graph. So enter on that. Then L1 is what we want, but our frequency is in L3. So second 3. Okay. And now if we graph, if your calculator is in color, it's a little bit harder to see. You might want to graph them one at a time. But mine is colored, so look at mine if you need to. You see for the blue, it's nothing's really too high. They're all fairly low, a little bit higher in the middle. Whereas the red one is very low at the edges and very high in the middle. Okay. So basically that means that it's more concentrated in the middle. Now sometimes students will say that that looks like something like giving someone the middle finger, which is not a good thing. But it means when it's really high in the middle and not much on the edge, that it's very concentrated around the median, or the median, or the mode. All of them will be the same. Later, like in June, we're going to talk about normal distributions, and that's where it's going to be the median, mode, all about the same value. Okay? So in this case, we can say, so we've done that, and you'll notice here the means are very close, but it's apparent that the marks for test 1 are widely dispersed, and marks for test 2 are concentrated between 11 and 13, basically. Okay, so when we talk about standard deviation, which is coming up in a minute, that value between those two tests, the standard deviation, will be much smaller for the test that's close to that mean or median or mode, that red one here. When it's all close in there, the standard deviation value will be small. This one, where it's all lower, the standard deviation will be bigger. Okay, so that's a concept that we're going to talk about and we have to know. All right, so having a small dispersion, or small spread or dispersion in test 2 may not be desirable as it does not differentiate between the abilities of the students. In contrast, manufacturers of precision instruments want a small spread on the dimensions of the items they produce, right? So that they're all approximately the same. Either way, it's important to have a way of calculating a numerical measure of the spread or dispersion of the data. The most commonly used measures are range, standard deviation, and interportal range. So we've talked about the range. That's just the difference between the highest and the lowest. Back in junior high, we talked about that. Interportal range, we learned the other day. That's the difference between the third quartile and the first. Okay, so about 50% of the data, that's really important to know how wide those are spread. But again, is that always going to be useful? Standard deviation it indicates how the values differ from the mean. And if you only would use that as a comparison for similar types of data. So a standard deviation with a value of 3 for a test, and a standard deviation of value of 10 for students' heights has no relevance, right, in terms of comparing how close those data values are. You need to be in context of the type of situation. All right, so in the next question here, determine the range of the following data. You don't need to enter them into your calculator. The range is just the highest minus the lowest. So do a quick scan, 81 minus 56. So that's 21, that's 25. Notice again, sometimes words in math, we use them in different contexts. The range of a function is the highest to lowest y values, or dependent variable values, right? Here in a group of data, it's the highest minus the lowest, the actual difference between them. Okay, so another word is variance, and that can be used very similar to standard deviation to compare the spread of data, and IB tends to do that a fair bit. So when you get to your IB exam in May of next year or the following year, depending if you're doing SL or HL, you will have some questions about statistics, okay? And they may ask for the variance. I've seen that more than asking for the standard deviation. The only difference between variance and standard deviation is variance is the square of the standard deviation. Or the standard deviation is the square root of the variance. So they're very easy to calculate. We're going to calculate by hand, but after this, you're just going to use your calculator. Okay? So, just to see how it works, we're doing this one by hand, but after that, we'll use our calculator. So, it says with this set of data here, okay, notice how it's just straight data. It is not a frequency chart. We're going to calculate the mean. Okay, so add them up and divide. Now, if you wanted to put them in your calculator, I guess you could, like in a list. But otherwise, you can just add them up quickly. It is windy. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 180 divide by 10. Alright. I think I answered those correctly. Okay, then calculate the deviations from the mean. So that means just the difference between your data value and the mean. So 12 minus 18 is negative 6. 14 minus 18 is negative 4. 16 minus 18 is negative 2. Put those in. Then square each of those deviations. Okay. Then add those up. then find the average, so the mean is the same as the average of the squared deviation, and that's what's called the variance. So 120 was the sum. There was 10 of them. I don't need my calculator. So that's going to be 12. Okay, so we calculated that is the variance. Now, just so you know, in your calculator, you'll see sigma and S. So we use the sigma standard deviation. Technically, if you take courses in university and get more involved in statistics, there's a slight different calculation when you're talking about data from an entire population and data from where you selected a sample. Okay, but for us, we're going to use the sigma. Okay, so we're pretending this is the entire sample, whatever these values are representing. That's right, this is in the entire population, not just a sample. Okay, so now take the square root of 12, and that's going to be your variance. And we usually use decimals. We don't use exact values. Now, saying that, I didn't say what to round to, so let's go to 2 decimal places. Okay. And so this is what we just did. So this is what we just did. We took the sum, right, that sigma notation, of all of the squares of the deviations. We divided it by however many there were, 10, and then we took the square root. So as you can see from this process, the standard deviation gives a measure as to how far the values deviate from the mean. A small standard deviation indicates that most values are close to the mean. A large indicates values are more widely spread, again, relative to the types of data that you're dealing with. For data in a frequency table, the formula to calculate the standard deviation is, so basically, you take that deviation. So say there was, this data had a frequency of 3 of them, and then 4, and 1, and 0, and 7, etc. We would take this deviation squared, then multiply it by the frequency, because there's 3 of them, and then divide by the total of the frequency. Then take the square root. Okay. And so next year, or the year after, in your data booklet, they'll actually give you these formulas. Again, I've never seen them ask you to calculate a whole set of data for standard deviation, but they might ask you to work backwards to figure out how many data values or something like that. They might give you some information, so just be aware that they're there. And I think they don't even put in the X anymore, they just keep it with the mu symbol as a population standard deviation. All right, so some more practice. Let's use our calculator to determine the standard deviation. Okay. And again, reminds you to use for population, which is sigma, lowercase sigma. Remember that the big summation kind of looks like an E is actually the uppercase, capital sigma. So stat, edit, go up and clear. You don't have to clear all your lists. You can clear just one of them, but I'm just going to clear them. Actually, we may have to enter them again, but that's okay. So this data, so enter just as is, 12, 15, 16, 18, 18, 19, 20, 21, 23, 24, 35. So I have 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So once you've got them in there, it's not a frequency chart, it's just a straight set. So we'll go to stat, calc, one variable stats, list one, frequency we just clear off. There's just one of each. Calculate, enter. Okay. So standard deviation, we use the sigma, they put a little x by it. I'm not quite sure, I guess standard deviation of the data values. In any case, let's go to the nearest 100. So 5.76. Okay, so the calculator can do it for you. Next one is a frequency chart. So you go to Stat, Edit, and clear off that list. Now my data values are 14, 15, 16, 17, 18. My frequencies are 4, 5, 8, 6, 2. Okay. Quit out of that. Stat, count, one variable stats. I put it into L1. My frequency, though, is in L2. Very common mistake on tests when we give something like this is students put both lists in, but here they don't put the frequency in. So it's just going to calculate every value, every property of just these values here. If you don't do that. Okay, so calculate on that. All right, so our mean then, so mean is 15.88. Oh, I guess it didn't ask for the mean. Standard deviation is 1.18. We go to 2 decimal places. Okay. Question 7, find the range of the marks for test 1 and test 2 listed on the first page and compare the two values. Okay. Then use the stat function. That's why I shouldn't have cleared it off. I totally forgot. To find the standard deviation of those. So let's go back to the first page. Okay, so our test 1 and our test 2, the range here, 15 minus 9 is 6, and it's the same here, right? Because we could use the same list. So the range of values is the same, but they're different distributions, right? Based on that graph that we saw. So, got to go back, stat, edit, clear off those lists, and got to do this again. So at 9, 10, 11, 12, 13, 14, 15, and then frequency 4, 3, 7, 8, 6, 5, 3. Then I'll put frequency for test 2. Okay. So quit out of that, stat, calc, one variable stats, L1, L2. That's good. That's for test number 1. Okay, and our standard deviation is 1.73. So here, so the range was 6 for both tests. And then the standard deviation for test 1 is 1.73. And then do the sentence. Calc one variable stats for L1 and L3. And that's 1.01. Okay, and then remember we talked about the histograms, relating the shape of the graph to the size of the standard deviation. Okay, so this one was the first test, and it was more sort of evenly spread out. So the bars were lower. So test 1, histogram bars were test 2. Okay, so now compared to the standard deviation. So when the histogram bars are all lower, standard deviation is larger. Okay, when the histogram is more concentrated, higher values in the middle, not much on the edges, then the standard deviation is lower. Again, it's a comparison, right? You can't say, oh, standard deviation less than 1.5 is going to be more concentrated in the middle. That 1.5 is relative to what kind of data you're using to start. So comparatively, standard deviation of test 2 is smaller than test 1. Therefore, test 1 is more spread out. Okay, so does the range or standard deviation give a better indication? Well, the range was the same for both. So obviously, it's the standard deviation gives a better indication. All right, so comparatively here, we've got 3 histograms. It says graph with the largest standard deviation is which one? Smallest, so basically the largest and the smallest. So you can tell me what they think is the smallest standard deviation. Justin? B. All right, so, oh, sorry. I switched the order of what I was asking for. Okay, And sometimes students get a little bit mixed up about A and C, but take a look at the ends, right? These ends are still quite low, still more concentrated in the middle, okay? But this is much higher here and low right outside of it, right? We don't know the scale vertically, so we have to, comparatively, this would be the smallest standard deviation, but this one compared to this would be the largest, because these are all quite high on the edges and sort of similar in between. Not much variation between them all the way through. So largest standard deviation would be A. Okay. All right. So weights in kilograms of 7 soccer players are given. Find the mean and standard deviation. So do that in your calculator, because if your mean is easy to do, without a list, but standard deviation, you're not going to do it by hand. Just clear off the frequency list. So mean doesn't say what to round to. Let's go to 2 decimal places. Okay, so over the season, each player's weight had increased by 5 kilograms, or not over the season, 3 years later, 3 seasons. Find the new mean and standard deviation. Okay. So what do you think? Do we need to even use our calculator to find the new mean? What do you think it would be? If each player gained 5 kilograms. Mean would increase by 5, exactly. Okay, because they're all increased by 5. So you can test it if you want. Maybe you might want to test it because you're not sure about standard deviation. But if every data value increases by 5, did any of them spread out anymore? No, because they all increase the same amount. So standard deviation is the spread. But if they're all increasing by the same amount, the standard deviation won't change. So if I'll put it in L2, so we'll just check. You don't have to check. I'll just put it in here so you can look at it. 5 kilograms, that would be 84, 69, 54, 76, 73, 79. 2. Okay, 70. Oh, what did I just do? I entered something wrong. What didn't I add correctly? So 5. Oh, that should be 64. Okay. Clear off, stacked, out. Okay, so 74.17, standard deviation 6.52. Okay, so adding the same amount to every mean does not change the spread, the standard deviation. So adding or subtracting. Okay. And last one, the weights in kilograms of 10 turkeys are given there. Find the mean and standard deviation. After being fed a special diet, the weights of the turkeys doubled. Find the new mean and new standard deviation. Okay, so let's compare that. So stat, edit, we'll clear off those lists. So 0.8, 1.1, 1.2, 0.9, 1.2, 1.2, 0.9, 0.7, 1.1. And then if we double them, I'm going to do that at the same time, just to put them in there. Okay, so stat, calc, one variable stats on L1. .01 and 0.17. Then if I do that for L2, .02, because you've doubled each value. So now your mean is double. Okay, so if you add the same value to every data value, you add that to the mean. If you double or multiply by a certain number every data value, you do that to the mean. Standard deviation did not stay the same as it did in the last one. When you're multiplying all the data values by a number, you have to multiply the standard deviation by that number. So standard deviation is 0.34, double 0.17. And you can see that if you take a look back at the formula. So here, if we're taking that data value, okay, doubling it, the mean's going to double as well. Okay, and then, oh, that's just a frequency. We don't care about that one. Here. So here, this one. So this is going to basically have a factor of 2 in here that's squared, which is 4, and then square rooted, which is 2. You think about looking at it as a factor. If we multiplied by 3, that would be each thing multiplied by 3, so 3 could be factored out. Squared is 9. Square root of 9 is 3. Okay, so the standard deviation will also double in that case. Okay, so questions that are assigned for this are in that extra booklet that I handed out to you. Okay, so you do have some time till 7 minutes after, so what, 15 minutes or so. And you're doing, oh yeah, that's the warning, 15 minutes. Exercises 8.2. Oh, actually, they're in your booklet, aren't they? Let's just check here. Oh yeah, exercises are actually in this booklet. I'm ready for a histogram. I have it already in there. Let's look at graph.
I wonder if it's select one graph.